Good day, class. Today we will discuss a new lesson, which is geometric sequence. Last time we already done discussing arithmetic sequence and what is the difference between arithmetic sequence and geometric sequence. That is a good question. So for arithmetic sequence, we have what we call the common difference. But in geometric sequence, we have what we call a common ratio, wherein the terms being multiplied to get the next term. Let us define first. When we say geometric sequence, it is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant, and that is known as common ratio. So we have the formula. A sub n is equal to a sub 1 times r raised to n minus 1. Just like the arithmetic sequence, we have this formula to get the term position, wherein a sub n represents the nth term. Your a sub 1 is your first term, the r represents the common ratio, and n represents the number of terms. We also have the formula for associated series or the sum of the terms. We have S sub n is equal to a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r, where r should not be equal to 1. Why? Because if r is equal to 1, the denominator will be 0 and it will make this formula undefined. Take note of the following formulas. This is for the geometric sequence, and this is for the associated series of the geometric sequence. Let us try the following examples and let us solve for the common ratio. How do we find the common ratio? We just need to get the second term and the first term. This is the second term, this is the first term, and then we will divide. So let's try. We have negative 12 divided by 6. Next, 24 divided by negative 12. Negative 48 divided by 24. 96 divided by negative 48. So in computing for the common ratio, we just need to get the quotient of the second term with the first term, third term with the second term, fourth term with the third term, and then fifth term with your fourth term. So when we divide negative 12 divided by 6, 24 divided by 12, negative 48 divided by 24, and then 96 divided by negative 48, the answer is negative 2. Meaning to say, for letter A, our common ratio is negative 2. Next, how about the common ratio of 1, 5, 25, 125, and 625. So same procedure, get the second term, divide it with your first term. Next, third term, divide it into your second term. Fourth term, divide it into your third term. And fifth term, divide it into your fourth term. 5 divided by 1, 25 divided by 5, 125 divided by 25, and 625 divided by 125 is 5. So the common ratio for letter B is 5. Now, letter C, we have 4, 8, 16, 32, and 64. 8 divided by 4, 16 divided by 8, and so on. So the common ratio is 2. Letter D, negative 3, 1, negative 1/3, 1 over 9. So let us divide 1 divided by negative 3, negative 1/3 divided by 1, and so on. The common ratio for letter D is negative 1/3. This is how to get the common ratio. Very simple, right? So in other words, we can use the formula to get the common ratio: a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, and so on. So class, you need to master it for you to solve easily the problems involving geometric sequence. Let us proceed with the next examples. What is the 8th term of the geometric sequence 1, 5, 25, 125, and 625? We already computed for the common ratio of this geometric sequence, which is letter B. And the common ratio here is 5. So we will write this on our solution. First, write our a sub 1. And based from the geometric sequence, our a sub 1 is 1. Our common ratio is 5. Next, our n. Our n is the term that we are looking, which is 8. That is our n. And of course, a sub 8. Because we are looking for the 8th term in this geometric sequence. So, first term, second term, third term, fourth term, fifth term, 6, and then 7, 8. What is the 8th term? Okay, in order for us to solve that, let us now apply the formula for geometric sequence, which is a sub n is equal to a sub 1 times r raised to n minus 1. Let's write a sub n is equal to a sub 1 times r raised to n minus 1. Let us substitute for the following values. A sub n here is the term that we are looking, which is a sub 8, the 8th term. A sub 1 is 1. Your common ratio is 5. And then n is 8 minus 1. Now let us compute. A sub 8 is equal to 1 times 5. 8 minus 1 is 7. So a sub 8 is equal to 1 times 5 is 5. 5 raised to 7. Or you need to multiply 5 by itself. How many times? 7 times. So you can use your calculator. 5 times 5 times 5 times 5 times 5 times 5 times 5 is equal to 78,125. Meaning to say the 8th term here in the geometric sequence is 78,125. So let us compute manually if our answer will be the same. The last term in the given is 625. So we will multiply 5 as the common ratio because 1 here times 5 is 5. 5 times 5 is 5 times 5 is 25, and then 25 times 5 is 125. 125 times 5 is 625, And then 625 times 5 is 3,125. This is the 6th term. And then for the 7th term, 3,125 times 5 again, that is 15,625. And for the 8th term that we are looking, we will multiply 5 again here. So times 5, that is 78,125. They are the same. So by using the geometric sequence formula, we can easily solve for the value easily. So that is our first example. Next, what is the 10th term of the geometric sequence for 8, 16, 32, and 64? Same procedure. Let us write first the value of our first term, or a sub 1. A sub 1 is equal to 4. Next, what is our common ratio? The common ratio is 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, 64 divided by 32 is 2. So our common ratio is 2. And then our n, 10. What is the 10th term of the geometric sequence? So this is our n, 10. And for our problem, we are looking for the 10th term of this geometric sequence. So this is undefined. In order for us to solve for the 10th term, so we have first, second, third, fourth, fifth, sixth, 7, 8, 9, and 10. For us to locate this 10th term, we will use the formula for geometric sequence, which is a sub n is equal to a sub 1 r raised to n minus 1. Let us substitute these values here in our formula. An is 10. Is equal to a sub 1 is 4 times your r is 2, n is 10, so 10 minus 1. Next, a sub 10 is equal to 4 times 2 raised to 10 minus 1 is 9. A sub 10 is equal to 2 raised to 9, that is 512. So 4 times 512, and our 10th term is equal to 2048. By using the geometric sequence, we already know the 10th term of this geometric sequence, which is 2048. If you want to solve it manually, you can. So let us try to solve. Since the common ratio is 2, we will just multiply 64 by 2 to get the next term here. So 64 times 2 is 128. 128 times 2 is 256. 256 times 2 is 512. 512 times 2 is 1024. And 1024 times 2 is 2048. They are equal. That is how you solve for the 10th term using the geometric sequence. Now let us proceed with the next problem. What is the sum of the 10 terms in example 2? So we need to compute for the associated series or the sum of the terms here in our example number 2. we need to use the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. For us to know the values of the following, let us copy the given. So our a sub 1 in our example number 2 is 4. Our common ratio is 2. Next, the n is 10. And our 10th term, a sub 10 is equal to 2048. Let us substitute the following here in our formula. S sub n is equal to, a sub 1 is 4 times 1 minus your r is 2 raised to your n is 10 divided by 1 minus your r is 2. S sub n is equal to 4 times 1 minus 2 raised to 10, that is 1024, divided by 1 minus 2 is negative 1. Let us continue. S sub n is equal to 4 times 1 minus 1024 is negative 1023, divided by negative 1. Next, S sub n is equal to 4 times negative 1023 is negative 4000, negative 1023 times 4 is negative 4092, divided by negative 1. Then simplify. S sub n is equal to positive 4092. Meaning to say, class, when we added 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048, the answer will be 4092. That is the sum of the terms. Given example number 2. Okay, so let's proceed with our last but not the least example. We need to evaluate the following sum: 1 plus 2 plus 4 plus 8 plus up to 512. So what are the terms represented by the 3 dots? Remember that the 3 dots is also known as ellipses. What are the terms represented by this one? Let us write first the following. Our last term or the nth term here is given, which is 512. So let us write. Next, our first term or a sub 1 is equal to 1. And then the common ratio or r is equal to 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, meaning to say the common ratio is 2. So let us substitute the following values in our formula. A sub n is equal to a sub 1 times r raised to n minus 1. Our a sub n here is 512. So let's write 512. A sub 1 is 1. R is 2 raised to n minus 1. We are looking for our n here, because we are looking for the terms represented by the 3 dots in here or the ellipses. So let's compute. Copy the left side. 512 is equal to 1 times 2 is 2 raised to n minus 1. Next, since we have a base of 2 here, we need to express 512 with base 2. And when we express 512 having its base 2, we can say that 2 raised to 9. So if you compute 2 raised to 9, the answer is the same, 512. So copy the right side, 2 raised to n minus 1. Now they have the same base, which is 2. Remember that if the equation has the same base, all you need to do is to cancel out the bases. So what is left? This will be cancelled out. 9 is equal to n minus 1. Then, transpose negative 1 to the left side so that n will only remain on the right. We have 9 plus 1 is equal to n. The sign of 1 change into positive. So, compute 10 is equal to n. Meaning to say, or therefore, the 10 here is the term for the given geometric sequence. There are 10 terms here for the given geometric sequence. Now let us evaluate the sum of 1, 2, 4, 8, and then there are 10 terms here plus 512. Using the formula, S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. Our S sub n here is 10. Next, a sub 1 is 1 minus your r is 2 raised to 10 divided by 1 minus 2. S sub 10 is equal to 1, 2 raised to 10, that is 1024. 1024, 1 minus 1024, that is negative 1024 divided by 1 minus 2, negative 1. So S sub 10 will be 1 minus 1024, that is negative 1023 divided by negative 1. Then simplify. Negative 1023 divided by negative 1 is positive 1023. Meaning to say, when we add 1, 2, 4, 8 up to 512, the sum of the terms will be 1023. So that is how to compute the geometric sequence. I hope you learned something for today. That's all. Thank you and God bless.